want to go over 6 problems to prepare for our Chapter 2 test. The first one being to determine if the function is symmetric about the x-axis, y-axis, or origin. So, for example, if we're given a function y equals x squared minus 6. Okay, we want to see whether or not this function is symmetric about. First we'll test the x-axis. To see if it is symmetric about the x-axis, we replace the y value with negative y and see if what we end up with is equivalent to the original. So, we replace y with negative y, so we write negative y equals x squared minus 6. Now this function is not equivalent to the original, therefore it is not symmetric about the x-axis. To see if it is symmetric about the y-axis, we replace x with negative x here, so we're going to get y equals negative x squared minus 6. Now in this case, if you take negative x and square it, you get an equivalent to x squared. Everything else is the same. Therefore, that function is symmetric about the y-axis. And to see if it is symmetric about the origin, we test both of them. We replace x with negative x and y with negative y. So we get negative y equals negative x squared minus 6. Now in this case, the x is okay because negative x squared is the same as x squared, but negative y and y, of course, are not equivalent. Therefore, that function is not symmetric about the origin. So the second kind of problem I want to go over is one where we want to solve for x, and we have x to the 1/2 minus 13x to the 1/4 plus 36 equals 0. Now this problem is set up perfectly for a substitution. Remember, when we substitute, we typically want to substitute in for this term. So in this case, I'm going to let y equal x to the 1/4 power. And by doing so, this becomes negative 13y. And what happens with this is going to become y squared. And the reason that's going to be y squared is because x to the 1/2 is equivalent to x to the 1/4 quantity squared. Because remember, we would multiply those exponents. So that would be 2/4, which is 1/2, so it's equivalent to the original. And since x to the 1/4 is y, we now can rewrite this equation as y squared minus 13y plus 36 equals 0. Okay, so now this is a much more manageable problem to solve. That is probably going to factor, and let's give it the 30-second test. And it looks like we can factor that into y minus 9 and y minus 4. So we want to set both those equal to 0, and y comes out to be 9, and y comes out to be 4. Okay, but those are not our answers because we don't want to know what y is, we want to know what x is. So now we have to resubstitute those back in, and so I'm going to, instead of make y equal x to the 1/4, say 9 equals x to the 1/4, and 4 equals x to the 1/4. And so now to solve for x, well, how do you undo something to the 1/4 power? You have to take that to the 4th power, but of course we have to do that to both sides. So x equals 9 to the 4th. In this case, same idea. X equals 4 to the 4th. The third kind of problem is an absolute value inequality. So if we had the absolute value of 3x minus 5 is greater than or equal to 10. Remember, absolute value means distance from 0. So if you think on a number line, and this is again not going to be our answer, but just give us an idea in terms of how to write our two equations. We need it to be more than 10 units away from 0. So if we go 10 units to the right, and more than 10 units to the right, it has to be out here in this region, and more than 10 units to the left would have to be to the left of negative 10. So to write this out here, we would say that 3x minus 5 has to be less than or equal to negative 10. And to write it for this portion, we would say 3x minus 5 would be greater than or equal to positive 10. And that's the hard part, is writing the two equations. Once we get these, we just want to solve them for x. We get 3x is less than or equal to negative 5. X is less than or equal to negative 5/3. That's one area of our solution. Add 5 to both sides. 3x is greater than or equal to 15, or x is greater than or equal to 5. So in interval notation, stuff less than negative 5/3, that's going to be negative infinity to negative 5/3, inclusive of negative 5/3, because we want the stuff that makes it equal to union, inclusive 5 to infinity. The fourth example is going to be a quadratic inequality that we want to solve for what values of x could make this true. So we want to know and solve for all x's so that x squared is less than or equal to 4x. Now, the common mistake might be to divide both sides by x, but we can't do that in this case. Number one, we don't want to divide by x because that's going to change one of our boundary points, and we will be losing part of our solution. So what we want to do is, because it's an inequality, we need to think key points and testing regions. So I'm going to move the 4x over. We get x squared minus 4x is less than or equal to 0. And to find key points in this case, we can factor an x out. And so now we can see that our key points, and remember the key points are whatever make this equal to 0. So we have 0 and positive 4. And because we have key points of 0 and positive 4, if you think on a number line, here's 0 and here's positive 4, they split the number line into this region, into the middle region, and into this region. And those are the places that we have to test. We have to test from negative infinity to 0, inclusive of 0, because we want the boundary points because they make the left side equal to the right side. We need from 0 to 4, inclusive. We need from 4 to infinity. So, we can take any value inside here and look at the factors here. So if I chose something like negative 1,000, if I take negative 1,000 and I plug it in here for x, well, this part is going to be negative, and this part is going to be negative, because negative 1,000 minus 4, of course, is negative. If I do a negative times a negative, that's going to be positive, which is greater than 0, so that is not part of my solution set. Then I want to choose a number between 0 and 3, 0 and 4, so a number like 3. So if we take 3 and plug it in here, of course 3 is a positive number. We take 3 and plug it in here, 3 minus 4 is negative. Positive times a negative is less than 0. This is part of our solution. Then we want to test something in this region, a large number like positive 1,000. Plug positive 1,000 into here, it's positive. Positive 1,000 into here, it's positive. Positive times positive is positive. Not less than 0, that's not part of our solution. So our solution is from 0 to 4, inclusive of both boundary points. All right, the fifth example, we want to find the equation with the given roots. So with the roots of, let's say, 3, negative 2, 3i, and negative 3i. So to write this equation, if we had it, there would be factors. Okay, think of this as our bottom line. The line above that would be the factors that generated those roots. So there would be the factors of x minus 3, that's where this came from. X plus 2, that's where this came from. X minus 3i and x plus 3i. And of course it's an equation, so we want to set it equal to 0. And so these factors would generate these roots. And now we want to know, well, what equation would generate these factors. Well, to do that, we just need to FOIL all this stuff out. So I'm going to take the first two and FOIL it out. We get x squared, the outer is plus 2x, the inner is minus 3x, and the last two multiplied together is negative 6. Then I will FOIL these two out, and we get x squared, the outer is plus 3i, the inner is negative 3i, that's nice, they're going to cancel, and now we have negative 9i squared. So I'm going to clean those up by combining my terms. So we get x squared minus x minus 6. And in this case, we're going to get x squared, 3i and negative 3i canceled. I squared is negative 1 times negative 9, which gives us positive 9. Okay, now we're not done yet. We still want to come up with the polynomial that would generate these factors. So I have to multiply everything over here by everything over here. So we get x to the 4th plus 9x squared minus x to the 3rd minus 9x minus 6x squared minus 54 is equal to 0. So to get our final answer, we need to combine all of our like terms. We'll write it in descending order. We get x to the 4th. We get minus x to the 3rd. Our squared terms, we have 9x squared minus 6x squared, which is plus 3x squared. We have minus 9x minus 54 is equal to 0. So this equation, if you were to solve it and find its roots, would have these roots.